Hello and welcome to another video. This is Cracking the Cryptic app Fog of War pack puzzle number 23, Cloudy Lemonade. The rules are Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column, and box must have all numbers from 1 to 9 exactly once. And Killer. The cells in each cage must sum up to the number in the top left corner of the cage, and numbers cannot be repeated inside a cage. Lastly, we have a custom rule, which is nothing more than a hint really, saying that numbers in cages are displayed in the leftmost cell of the topmost row in which the cage exists. Let's begin. So this is just Fog of War Sudoku plus Killer Sudoku combination, and these combinations are usually very, very fun. So we're given vision of a cage that starts here, and we see that it goes downwards. And not only does it go downwards, but we also see that it sums up to the number 4. Now, a cage like this cannot possibly be 3 cells long, because digits cannot be repeated inside cages. So therefore, if it was 3 cells long, it would have to be 1 plus 2 plus 3, which would sum up to at least 6. And therefore, this has to be exactly 2 cells long, meaning that the only numbers that can fit in here are 1 and 3. Now, on the right side, we see a cage that sums up to the number 43. And we do know, in fact, that this currently selected cell is the top leftmost cell of that cage. Because if you remember the Killer Sudoku rule, the indication of what the cells sum up to always goes in the top left corner of the cage. Therefore, this cage cannot go to the left or anywhere upwards, ever. Because if it did, then that square that's here or higher, right? Then that would be the top leftmost corner, and that would have the indication of what the cells sum up to. But it doesn't. So it can only go down and stay on this row. Now, we also do know exactly how long it is, because you can only have the number 43 in a Killer Sudoku by summing up all numbers from 1 to 9 except for the number 2. So therefore, it is exactly 8 cells long. We can test that pretty easily. So 8 cells, that works, has all numbers from 1 to 9 except for 2. 9 obviously doesn't work because that would sum up to 45, and 7 doesn't work because that is too low. So 1, 2, 3, 4, 5, 6, 7, 8. Let's color it red. And we do know it contains 1, 3, 4, 5, 6, 7, 8, and 9. So let's just quickly fill in every other possible cell with every value that that cell could take, because that is going to make our job a lot easier. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, the only place where the number 2 can go in his bottom row is right here. So that is the number 2. And look at this, we have a 1 free pair right here. So that means that nowhere else in the same column or box can the numbers 1 or 3 go. And furthermore, this is a cage that must contain numbers 1 and 3. So if this is a number 1, then that means that number 1 is nowhere here, right? But if this is the number 1, then because this cage must contain the number 1 would go here, so once again, number 1 would not be in any of these squares. And since number 1 goes here or here, and they both imply the same thing, that means that this thing does not contain the number 1. And it's the same with the number 3. So if a number 3 is here, none of these cells contains the number 3. And if the number 3 is here, then because this cage must contain the number 3, and it's nowhere here, then it would have to be here. So once again, none of these cells would have the number 3. Now, we've seen something new. Another piece of information was just revealed, namely that this is a square, this is a cage that sums up to at least, that sums up to 7. And it is at least 2 cells long, since we see it extending in the fog. Now, obviously, that gives you some sort of an indication of how high these cells can be, right? they cannot contain 9, 8, or the 7 itself. And because the minimal value here is the number 2, then neither of these can be the number 6. Because if that was a 6, then this would be a 2, so they would sum up to an 8. And now this also cannot be the number 5, because that would force this to be the number 4, which would equal 9 and not 7. For the same reason, this cannot be a 4, so it must be the number 2, and therefore this must be the number 5, because now we do see that it is exactly 2 cells long. Alright, so this now reveals some more information. Namely, we see that this is also a cage, and it is a cage that sums up to 14. So, therefore, we have to treat it that way. Now, it cannot contain number 5 anywhere, so we can remove all cases that contain the number 5, and it must contain the number 2, but it cannot contain the number 3, because 3 is over here, right? So that only leaves you with a single case where it is, in fact, 2, 4, 8. So it cannot be anything except for that. It cannot be a 6, cannot be a 7, or a 9. So that means that 4, 8 is a pair over there, and we cannot have 4 or 8 anywhere else in that column or box. Now, that also reveals some new stuff here. We see that we have a cage that does not have an indication of what it sums up to, and we do see that it goes upwards like this. So we're going to color it with the pink color. We're going to have a lot of repeating colors because I really don't want to use dark. Like, this color makes it really hard to see what's inside, and then this color, it just, well, this one is actually pretty usable, but this one, like, I can barely tell that it's even colored, so I'm not going to use that. But this is actually usable. So I should just remember that this one is usable. So let's just immediately use it, actually. So, okay, there we go. The 11 goes like that. We don't know if it goes out any further, but we do know that it doesn't go upwards, because if it went upwards in any way, right? That would cause a contradiction with the fact that this is the top leftmost corner of the cage. And we have a 40, which also goes like this. So let's color it orange again. And this 40 also does not go upwards because this is the top leftmost corner of the cage. Now this is actually very interesting because 40 is a really high number. So how many cells do we need to even get the number 40 at minimum? So 6 cells doesn't work. So at minimum, you need 7 cells, and at most, you need 8 cells. And it cannot go upwards, right? Nothing like that works. And we have a limited number of cells free. So 1, 2, 3, 4, 5, 6, and 7. So it ends up taking this whole region. And it cannot be 8 cells long, so it cannot be that case. It must instead be exactly this case. Okay. And can we rule anything further out? Well, I don't think so. So, does it 1 or 4? Does that matter? 2 or 3? Nope. Not sure yet. But let's try to see if maybe we can do something with this 11, because this 11 now has to be exactly 2 cells long, because it is surrounded by cages on all of its sides. So can this be a 9? No, because there is no number 2 to make the 11. It cannot be an 8 because it's missing a 3. Cannot be a 6 because it's missing a 5. So that's a 4-7 pair. Oops, yeah, so like that. 4 and then 7. Pretty nice. So that gives this a number 8, and then this is the number 4. And a new cage is revealed here and up there. So this is a cage that goes upwards. We should color it red maybe, and then this is an 11. So we're gonna color it. So why don't I like coloring things blue? Because it just makes it a bit awkward to see. For example, number 2 should be right here, right? And it's a blue color. So because those cells that contain number 2 are also colored blue when you select it, it just looks a bit awkward, so I don't like using that color. Maybe yellow again. So I'm just spacing colors out in such a way that it's not possible for them to connect. As long as we don't use colors, for example, if this was an orange, that would be weird, right? Because it looks like it connects with this, but as long as it's not connecting anywhere, it's fine for me. Okay, so that reveals a 6, 9, 6, 9 here. So that means that nowhere else in this box can you have 6 or a 9. And that shows you that this and this are actually a 1 free pair. All right. Now, what else can we do? So number 4 is obviously not a part of the 40 because 4 is not there and 4 is not here either. So it must be the 2, 3, 5, 6, 7, 8, 9 case, meaning that it does not contain the number 1. And it must contain the number 2, so the 2 must be somewhere there. Okay, 2, 3, 5, 6, it must contain the number 6, right? And 6 is here, and 9 is here. So since we have the 6, 9, it cannot be anywhere else in that cage because digits cannot be repeated inside the cage. So since we've already found the 6, 9 pair, that means that 6 and 9 cannot be anywhere else in that cage. So 2, 3, 5, 6, 7. Okay, so a 7 has to be here because a 7 cannot be here or here. And since a 7 must be a part of the 40 cage, that must mean that a 7 is not down here. And now, since a 7 cannot be here because of this, and a 7 cannot be here because of that, the only place left for the 7 in this 43 cage is right in this square. So that's the 7. And now we have a 6, 9, 6, 9 pair, meaning that this is not a 6 or a 9. All right. What else can we do? So 8, 9, I don't think there's anything else probably with the 40 cage. What about this thing? This thing, 1, 3, 5, 6, 8, 9, 3, 5. Let's just check the digits maybe. 5, 8, 6. I guess this is where I should pay attention to. Because they must make an 11, so this is either a 5 or a 2. So it's not a 3, 4, 6, 8, or a 9, right? Or a 7. Because it's just 2 cells long and it makes an 11. Now, what can we do? There has to be something that I'm missing. Namely, I think this, this is the number 1. This is the only place in this row that can contain the number 1. So that's the number 1. And now we say that this sums up to 15. And since we're only looking at cases that contain the number 1, and 6 and 9 are here, then this must be a 5, 8. All right. Now, if this is a 5, then that would be an 8, right? But if this is a 2, then this has to be a 9 because they make an 11. So since this is a 9, then this is a 6. And then this has to be the 5 because 6... No, then this has to be the 8. Okay. So if this is a 5, then this is an 8, and we're done. And if this is a 2, then this is a 9, so this is a 6, and now this needs an 8 over here in order to make the 15. So in both cases, if this is a 2 or if it's a 5, the number 8 must be here. And therefore, by elimination of disjunction, the 8 simply is over there. Now, that means that this has to be the number 6. So this is a 9, and then this is the number 2. Okay. That does reveal some new stuff. That reveals a 27, which we shall promptly color. And it also reveals another 27 cage, which we shall color green. So, how do we do this now? Maybe check if we're missing something. I don't think we are, though, because there simply isn't a lot of information that's free. We barely have digits put down. So let's just check the 27. So in order to make the 27, we must make use of the number 9. That means that the number 9 is nowhere else inside that box. Now, we don't actually... All the other cases are variable, right? But it does not contain number 1 or 2. So number 1 cannot be anywhere else. And it's the same here, right? This has to contain the number 9, and it cannot contain numbers 1 or 2. All right. So what can we do? Well, since this must contain the number 9, and the number 9 isn't here, then number 9 is nowhere else because it's somewhere here, right? Yeah. And so it must contain a 9. So this cannot be 5, 6, 7, 9. Why? Because this square right here is neither a 5, a 6, a 7, or a 9. So that means that for this selection, this is not a 5, 6, 7, 9. So it must contain an 8. But the only place where it can contain an 8 is right here. So therefore, that's the 8. And now, this is... So now, this is 3, 7, 8, 9, or 4, 6, 8, 9. So in neither case can it contain the number 5. All right. And now, since this cannot contain the number 8, then that must be the case of 5, 6, 7, 9. So this is not 4, 3, 6. Oh, no, it can be a 6, right? So 5, 6, 7, 9. Okay, that's everything. All right. What else can we do? Well, number 1 must be either here or here. So it cannot be anywhere else. Number 3 must be up there as well. So it cannot be anywhere else. And now, since number 1 in that box can only be here or here, and the number 3 can also only be here or here, then that is a 1 free pair, meaning that no other digit can be there. Or in simpler terms, we have a quadruple 5, 6, 7, 9, so we can remove 5, 6, 7, 9 very simply, and then that's a 4, so this is a 1 free. All right. That does reveal some new stuff. Namely, we see that this that's how it goes. That this whole thing is a cage. So since it already contains 1 and 3, it cannot contain 1 and 3. And we see that it is 1, 2, 3, 4, 5, 6, 7, 8 cells long. At least 8 cells long, right? And it cannot be 9 cells long, so it is exactly 8 cells long. So we have the exact length of that cage. Okay. And we therefore see that nowhere in that cage can there be a number 5. Okay. So it must contain the number 2 somewhere, and the only place it can contain it is right here. So that's the 2. It cannot contain the number 4 anywhere because it's already containing it. And now 6, 7, 9, that's a triple, so that's the only place for the number 8 to go to. All right, so now we see that we have a cage snaking upwards like that. So this does help us in a certain sense. For example, can this number up here be a number 3? Well, if that's the number 3, then you cannot have 3 anywhere else in the cage, right? Let's just, so if that's a 3, then number 3 is nowhere else in the cage, and it cannot be anywhere else in the same row, so number 3 would be nowhere in this box, which is a contradiction. So number 3 cannot go up here. And same is true for number 4. And same is true for number 5. So that is a 6, 7, 9. And now we have 6, 7, 9, 6, 7, 9, and 6, 7, meaning that that's a triple. So nowhere down here can we have 6, 7, or a 9. Okay. So since that's a free 4, ooh, that is touchy. But let's take a look at this 27 again. We know that a number 9 is here somewhere. And we know that this thing contains either an 8. No, it contains an 8 definitely, right? But over here, it contains either 3, 7 or a 4, 6 along with the 9. So if it contains 3 and 7, then a 6 would be here, meaning that 6 or 7 are nowhere else here. And if it contained a 4, 6, then a 7 would be here, so again, 6 and 7 would not be outside. So no matter the combination, because this is either a 6 or a 7, it's ensuring that nowhere else outside can this be a 6 or a 7. And now that's a 2, 5 pair, so nowhere else down here can we have 2 or 5. And now, since this is a 3 or a 4, and you can only have one such low value, then this cannot be 3 or 4. So one of them is a 9 and the other is a 6, 7. So because a 9 is here or here, that must mean that it cannot be anywhere else in that same column. All right. So 358, 358, and 35 means that this cannot be 3, 5, or an 8. So that is a 6, and therefore this is the 9. And now that's a 7979, and that tells us exactly in which case we are, because number 6 cannot go there anymore. So since that's a 79, then this must be the number 3. And therefore, this must be the number 6, because we have a 7-9 pair. So that's a 6, that's a 5. And we'll deal with this in a bit. But that does tells us that, so 3-8 cannot be anywhere here. And now, what else can we do? So a new cage is revealed, and it is at least 3 cells long. Let's make it red again. This is the number 4. So we see now what this sums up to, and a new cage is revealed, goes like here in fog on both sides. There are so many cages actually, and there's also a cage up there as well, going at least like this. All right, so let's check this. The 28. So the 28 contains the number 4, meaning that we should kill all cases that don't have the number 4. Furthermore, it cannot contain the number 2. So we should remove all cases that have the number 2. 1, 4, 6. It does not contain the number 8. So it cannot be this case or this case. So that is 3, 4, 5, 7, 9. So it cannot have number 1 anywhere. It cannot have 6 anywhere. So 3, 4, 5, 7, 9. That is over. Yeah, that's exactly it. And now number 6 must be somewhere up here. And same is true for the number 4 and number 1. So this is a 1, 4, 6. Yeah, because this is 3, 5, 7, 9. Yeah, that's a quadruple. So this cannot be 3, 5, 7, or a 9, meaning that this is 6, 1, and then 4. So this is also part of this cage. Let's just color it, because that makes it prettier. So this is the number 3. This is number 1. And we have a 1, 4, 1, 4. So you cannot have 1 or a 4 in this column, forcing this to be the 7. And this is the 4. And now, what else can we do? I'm guessing that very shortly I'm gonna have to start reasoning about this and this. So let's start maybe with the 12. So 12 does not contain 8 or 9, does not contain the number 4. Can it be 3, 4, 5? No, it doesn't contain 4. So it is either 1, 5, 6, which would work, or it is 2, 3, and 7, and that would also work. But can it be 4 cells long? Let's check. If it was, then it could either go down like this, right? No, actually it doesn't go this way. There's a barrier. So it would have to go down like that. So 1, 2, 3, 6, that works. 1, 2, 4, 5, that also works. So we don't really know much about this here, but we do see a 7, 9, 7, 9, meaning that this cannot be a 7, 9. All right. And this is a triple as well. 5, 7. Wait a second. No, it's not a triple. My bad. But number 3 is just here, right? Because that's the only place where the number 3 can go. So I should probably just go through all the digits because we've placed so much stuff that some stuff is bound to open up. So number 1, number 2, number 3, 4, 5, 6, 7. Okay, so yeah, 7, 9 is not here. Okay, that changes things a bit. Okay, 7, and then right, so 7 is here or here, meaning that it cannot be anywhere else here. Actually, we have a triple over there, so that is not 7, an 8, or a 9. Now let's check the 8. So an 8 must be a part of the 16. That is pretty good to know, because then the other 3 digits have to sum up to 8. And this cannot be 5 squares long. Actually, that is impossible, because so that is because it contains an 8. So the only way it can be 5 cells long is if it didn't contain an 8. And when it does contain an 8, it cannot be that long. So let's check the case that contains an 8. And there is only 2 of them, right? The first one is 1, 2, 5, 8. So 1, 2, 5, 8, that would work. And the second one is 1, 3, but it does not contain the number 4, because 4 is over here. So this can only be 1, 2, 5, 8. So this cannot contain the number 3. And since this is now a quadruple, that must mean that this cannot be a 1, 2, 5, or an 8. Therefore, this is a 3, this is a 6, and now we do see that this 12 is actually 4 cells long. And if we check the exact case, it must be the one that contains the 3 and 6. So this is the 1, and the other number is the number 2. Okay. Now this must be the number 5. And this 18 is 4 cells long, going like this. And there's also the number 30, which goes down like just here. Now, obviously, this 18 cannot be just 4 cells long, because this sums up to a 10, and this has the maximum value of 6. So therefore, this must go at least one further, right? And we actually do see that it goes further in fog. My bad. So since this sums up to a 10, this must sum up to an 8. So it cannot be the number 1. It cannot be the number 4, And it cannot be the number 5 because it doesn't have a 3. So that is a 2, 6. And therefore, you don't have 2 or 6 anywhere in that box or row. Now, does that tell us anything? It's bound to resolve itself soon. So 2, 8, 2, 8 means that this must be the number 5, and so this is the number 1. So this is the 8, so that's the 3. This is 4, 5, 4, 5, making the number 9, and therefore you don't have 4 or 5 anywhere else. These two sum up, sorry, these two sum up to the number 13. Why can it only be those two? Well, because an indication of what the cells sum up to is in the top leftmost corner. And it can only go right because it's bounded on the bottom side, and it cannot go upwards because this is the top left corner, right? So now, can this be a 9? No, because there's no 4 to make the 13. 8? Well, 8 is missing the 5. So that is a 6, 7. And finally, something might open up, so that's a 6, 7, this is the 5, and then this is 9, 7, 9, and then 7, so that's a 5, 7, 6, 9, 9, and then lastly 7. And the puzzle is still not giving up. So we see that over here we have a cage that sums up to 7. Now, if this is a 5, because there is no number 2, that will be too high. And same is true on this side, this cannot be a 5. So, if that is 3, plus 4 would make a 7 immediately, and the same way around if this was a 4, but I'm considering, can this be a 1? Well, 4 and 1 are a 5, and you're missing the 2 to make the 7. And 3 and 1 are a 4, but you're missing the 3 to make the 7, and you cannot have 1 and 2 because the 2 is here. So this cannot be the number 1, meaning that this is a 3, 4, and therefore cannot have 3 or 4 anywhere else. So that's a 1, and then that's a 5. So this is the 30. And now finally, I think this puzzle might be close to being solved. So, 4, 8, 4, 8. 5 goes up here, 4 is there, and now 4 is here. This is a 1, then that's a 1, 8, 4, 3, 4, 3 is up here, and number 1s are solved. 2 is still a bit tricky. I don't want to look at this yet. 4 is solved. 5 must be here, and now it's solved. 6, so 6 is either here or here, meaning that this cannot be a 6, so that's a 7, 6, And then this is a 7, 2, 9, 8, 6, 2, 7, 9, 6, 8, 9, 2, and lastly the number 8. Alright, that was a fun puzzle. Thank you guys for watching, and see you in the next one.